Meow 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 meow.
Hello, and welcome to a video. So this is going to be the reboot of the Super Circuit Bending Super Show. So I'm going to yap for a little bit about what that means and like what this is and stuff. If you don't care about that and you just want to see some circuit bending, you can go ahead and skip ahead. We're going to be circuit bending this guy. And yeah, I'll try to like make chapters or whatever it's called when you make it easy to skip to stuff. But yeah, so I mentioned this was the reboot. So brief note, originally when I came up with this concept, the whole like kind of idea behind it is that circuit bending is really fun and cool and has this very like as you'd say, kind of like this very DIY punk rock thing to it that I always really appreciated as someone who has kind of come up in that that whole subculture, and you know, really appreciate just kind of being able to tear into things myself, not need to you know, have a tremendous amount of preparation or education on the subject, just kind of go for it. And circuit bending has a lot of those qualities, but it always felt like there was some weird barrier to entry. For me personally, at least, it took like over 10 years of being like super interested in the idea to like sit down and try it. And I really enjoyed it. So I'm hoping with this series to be able to like make it a little bit more approachable. That's kind of the whole overall goal of this. The specifics of how I first attempted to do that, I thought, okay, I will just show this like whole process, the whole thing, warts and all, and I did it in the form of a live stream, and that didn't work. It was not a great idea, mostly because it just ended up being like really, really boring. And I don't know if by the time I post this, if I'm going to have taken those old videos down or not. I probably should. They're not good. But, yeah, I've probably taken them down. They might still be up. But even if they are still up, again, I kind of don't recommend watching them because they're not very good. It was really short-lived because, yeah, it just wasn't working out. So with this reboot, my attempt is to ultimately do the same thing, right? Like, make this more approachable. I still want to show the full process, warts and all, but I am going to be doing it pre-recorded, but with some minimal editing to take out a lot of the dead time where I'm, you know, hemming and hawing or, you know, scratching my chin trying to figure out what to do next, or, you know, even simple stuff like on this guy, there's like a jillion screws on the back, and it's really freaking boring to watch me unscrew a bunch of screws. So, you know, with a little bit of editing, we can skip through all that stuff. And as it goes on, maybe I'll do more editing, but for now it's going to be super minimal. I'm just going to keep like a nice overhead desk view like this, talk through what I'm doing, do close-ups as I need to, and really just kind of very simply edit things together. And again, keeping the focus on keeping this very approachable to people who know nothing about electronics, nothing about circuit bending. So I'm going to try to keep things super approachable and always explain what the hell I'm on about. But I will kind of openly invite now if I'm ever bad at that or use some weird term or forget to explain something, you can always ask questions in the comments. One nice thing about being a teeny tiny channel is I actually get to see all the comments, and I will answer if any questions crop up. So that's a plus of this being a super small niche thing. So anyway, ask away if I might totally skip over something or confuse the hell out of you on something I say at any point. But I'm going to try my best to preempt any of that confusion and just make this overall really, really approachable. Just a couple more things that bear mentioning before we kind of dive right in. On a little bit of a personal note, you'll notice I wear this goofy glove here, and that my hand kind of does its own thing and just kind of like shakes like crazy. You're going to see that happen. So just to be upfront about what that's all about. I had a stroke about a year ago, and yeah, my whole left half kind of doesn't work very good. It's working way better now after lots of rehab. I'm hoping that eventually it'll kind of come all the way back through some hard work and whatnot. So maybe we'll get to see that improve over time. But for now, this thing is pretty useless in terms of, the fine motor skills needed for soldering and working on things. So anyway, mostly just saying that because y'all are going to see it. That's what's up with it. And yeah, because it's like a brain damage thing, it's illegal to be mean about it. So you can't say anything mean. The other main reason I bring that up is the way that I solder is just a way to kind of make it work one-handed. It's not how you should solder. So if you're watching this as a complete beginner and you're like, why is he soldering that way? Or you think, that's how I should solder, I just want to be upfront. No, it's not. I highly recommend going to watch a video on, here's how to solder properly, made by someone with, who can use both hands and do things properly. I always recommend look for like a 20 to 30 minute video, because there's a million like 5 to 10 minute videos, but those suck. Look for a decent tutorial that's gonna be really thorough. So yeah, just a disclaimer, my soldering sucks. I know it. You don't have to leave a comment telling me I'm doing it wrong. It's a way of kind of adapting to being able to do this. And honestly, with circuit bending, you don't need to be super good at soldering. Again, with part of that being super approachable. If you can solder well enough to make things stick together and conduct electricity, then fuck it, you did it. That's all that really matters. So, all that to say, yeah, I got a weird hand. You're gonna see it. And the way I solder is wrong. So, anyway, the last thing I'm gonna yap about before we get started is this guy. And why I'm choosing to start out with this guy, because that was something I kind of hemmed and hawed over for a long while. I decided on this guy. I'm not gonna lie, this is like my second go-around, because the first time I sat down to record this, I completely beefed it. I was on a deadline for like an exhibition at Open Sauce, and it turned into a whole mess. But I was really determined to do specifically a mod on this keyboard because, one, it's super available, and that's kind of the heart of circuit bending. Right, there's a lot of times we hear about old Casio keyboards, especially the SK1 and the SK5. Those are really popular circuit bending projects, and I definitely intend to do those in the series. But it's important to note that the reason those were popular to circuit bend is they were all over thrift stores in the late 90s, early 2000s. You could find those things for $3, $5 at any thrift store in the country, just because there were so many of them. Less so these days, where now they're like $50 to $100. And that's still, doable for a lot of folks, especially if you are after that specific kind of circuit bent Casio sound. I think it's worth it. But in general, especially if you're getting, you're just now learning how to do this stuff, it's pretty intimidating to drop $100 on something and then circuit bend it. So I wanted something that you can actively still find these in thrift stores, or this one I bought it off Amazon, I think for $25. So not the cheapest thing, but you can get these brand new right now at Target. Order them off Amazon, or just wait till one crops up at your local thrift store. I've gotten a bunch of these for $2 and $3. They're still floating around. And the other reason I wanted to talk about this is a lot of the more modern toys, as we're going to see when we get into this, they use what we kind of call a system on a chip, or an epoxy blob, where basically 90% of what this thing does all just happens on one little chip, one little blob of silicone. And there's not much in the way of, circuit bending that you can do to it, because all those functions are built right into that processor. Right. And that's kind of more and more the direction things are going as microprocessors become super cheap, and people who can make software are way cheaper than people who can make hardware. So you see a lot less of the stuff like you do in the 80s, where you have big ROM chips, lots of through-hole components, and it's really easy to do what we think of as circuit bending, where we find these glitches and cross different wires to alter circuits. That stuff is really easy with 80s technology, but with more modern things, there's really not as many points to bend. So one of the reasons I kind of want to lean into that is the more approachable stuff is actually much harder to bend. And I think the way that, this is just my opinion, man, but I think the way that that's going to impact circuit bending at large is it's going to see more of a shift to modifying things. Just to give us a little bit of a vocabulary, if we think of, crossing a bunch of wires to break the internal circuits just by changing up the connections, if we consider that circuit bending, then we might consider modding, and we're not really altering circuits, but we're adding in effects, we're adding delays, we're changing clock speeds, things like that. And this keyboard is one that's fairly easy to modify, so it's a great candidate to kind of display what I mean when I talk about modifying versus bending. What we're going to do with this one are two things that I would consider mods, because we're not really changing anything per se, where we're more like adding on to what's already in here. The first of those is going to be a clock modification, and you'll often see this referred to as a pitch bend. But how this achieves the pitch bend is there's a little crystal oscillator inside this thing that we'll get a good look at here in a few. But what you do is you basically install a board that lets you change that clock speed. And so basically you are overclocking or underclocking the little CPU that I mentioned. So you can't really get in there and circuit bend everything that's happening on that CPU, but you can change its reference stable clock speed to slow things way down, speed them up. And as things slow down or speed up, that of course will change the pitch. And so that's why a lot of times you see it referred to as the pitch bend. The second thing we're going to do is install an LFO circuit, and basically it's a little circuit I've thrown together that lets you control an LED, much like you would an LFO on a synthesizer. So you can select different wave shapes, you can change the speed, change the intensity, and basically what this does is instead of sending that out as a control voltage like it would on a proper synthesizer, it will actually just send it straight to an LED. And as the brightness of that LED changes, we can use a light-dependent resistor, or LDR, to basically interpret that light brightness and change it to resistance. So when we put in our clock mod, we're going to install a knob, and that knob basically lets us change resistance to control the clock speed. But the LFO will also be able to do effectively the same thing, but rather than us physically turning a knob, we'll be able to set basically a pattern of a rising and falling wave, and let that pattern control the changes to that clock speed. So that's a little hard to conceptualize, I realize, but we're gonna get into it, and it'll be a lot more clear what I'm on about as we get there. So without further ado, I think that's everything I wanted to yak about. I'm sure I'll remember more stuff as we go along, but let's go ahead and start breaking into this thing. So like I mentioned before, there's like a jillion screws in these things. And I'm not going to sit here and make you watch me do that. So I'll either like do a little fast forward-y thingy or skip ahead. We'll see. I'm not sure yet. We'll figure it out in post. Yeah, and I already thought of something that I forgot to mention. So off to the side here, I have a little parts bin. You can see I've got pieces from another Meowsic already in here. But if you are just getting started with this stuff, start grabbing little containers like this, especially the ones that have a bunch of little dividers. They are fantastic for projects like this, because you can, put all the exterior screws you take off the back, you can stick those in one little compartment, and then all the screws you take out of the first circuit board, you can put in a separate compartment, etc. I've taken apart a few Meowsics, and I know that all of these screws are exactly the same. Actually, the ones on the circuit board might be slightly different, so I always keep them separate. But, long story short, I don't mind mixing the parts from several Meowsics together, because it's all the same anyway. One stubborn screw that wouldn't come out here. I'll try to knock it loose. Now, when opening these guys up specifically, they have a few points where they kind of like click into place. I appreciate they built these things super solid, knowing that they were for little kids. But the ears, especially, just if you start opening ears up and you're like, oh, it's really stuck on the ears, don't be afraid to use a little bit of force. Because that is supposed to happen. This is another area where the wobbly hand can get a little annoying. It can be hard to get purchase on stuff that would normally not be too hard. So I'm just using a pair of tweezers to kind of pop these two halves apart. You probably won't have to worry about that. But if yours is super stuck together or something, it's called a spudger. You might see me use one at other times. But they make little prying tools that are generally pretty safe for plastics and electronics. And those things, again, they're called spudgers. Those are super useful. But on something like this, where I'm not super worried about damaging anything, because it's built super tough, it's not like a super expensive thing. I would not be this laissez-faire if it was, obviously an expensive piece of gear. But on something like this, you got a lot of wiggle room. Alright, so let's get this guy opened up. And the first thing I'm going to do is you'll notice there's a lot of tape in here. And I'm just going to free this up so that I can move this back piece around without having to desolder. If you can see these wires, the battery compartment's right there. And if these wires are really bugging you and they're in your way, all you have to do is desolder those wires. Make sure to take a picture so you know where they came from. And you put them back in, because if you put them in backwards, it'll blow something up. But yeah, it's easier, in my opinion, just to peel off some of this tape so you get a bit of flexibility. Disconnect the microphone as well. And as you can see now, I can flip this back piece off and kind of stack it like this. And the nice thing is, because everything's still all hooked up, I can still turn this on. And that way, as we go, I'll be able to test stuff out. One really important thing about circuit bending that you'll kind of learn as you go is kind of setting yourself up so that you can test things out as you're bending is a huge help. So making it as easy as possible to kind of flip it on and see what your mods are doing. So that's one of the reasons why, in addition to just being lazy, let's be honest, why I'm leaving everything hooked up, is it makes it really easy to just kind of switch it on and test stuff out if I need to. Yeah, let's take a closer look at this board. So you'll notice I'm zooming in on this board here. This is where like all the magic happens on this keyboard. I know that because I've taken a few apart before, but I'll try to talk about how I know that or how I learned that so that you can follow along. So one main clue that this is our primary board, as opposed to say something over here, is when we look at the wires coming from the power switch, they all come to here. So our battery connects to this board, our power switch connects to this board, our speaker connects to this board, our microphone connects to this board. Basically, everything else is all connecting to this board. So that kind of tells us this is where most of the logic of the machine is happening, right? Since everything is coming into this. So let's talk about what we can see on this side of the board. And if you're not super familiar with electronics, that's fine. You don't need to be. I'm going to talk a little bit about what these things are, just because it is helpful to start to learn that. But if you're struggling with it, or if it doesn't stick with you, don't sweat it too much. It's not that big a deal. So these two guys right here, these are electrolytic capacitors. And basically what capacitors do is they kind of act like tiny batteries. They smooth out the flow of electricity by storing a little bit in the capacitor. And that way, instead of, you can think of electricity as kind of going up and down constantly, right? It's like high, low, high, low, high, low. Just the way if you know about light bulbs, basically are just blinking really fast, and it's so fast you can't see them blinking, so it looks like they're on all the time. Electricity kind of works the same way. So what a capacitor does is it stabilizes that up, down, up, down, up, down by storing a bit in here, and that way you can kind of feed a constant supply of that upper trajectory. So this really helps you kind of get your voltages smoothed out. So it's a really common component. They're in almost every circuit you're going to look at. And the reason I point out that these are electrolytic is there's a few different kinds. And electrolytic ones can sometimes, any electronic component can fail, but cheap or just really old electrolytic capacitors are kind of one of the first things you suspect if you're looking for a failed component. Especially in audio gear that's just being really noisy, because these also help to limit noise and smooth out power supplies, things like that. So that's what those guys are. They're just a couple of electrolytic capacitors. They're smoothing out some kind of voltage. This guy right here is an inductor. These will look a bunch of different ways. Sometimes you'll see them as just like a coil of copper wire. And basically that's what this is. It's just like a coil of conductive material inside this little shell. And what that does is it basically kind of boosts the voltage a little bit as it comes through here. And again, if you're hearing me describe this, I'm not an electrical engineer. I washed out of electrical engineering school. So if you hear my explanations and you think they suck, feel free to leave a comment with a better explanation, because Lord knows mine are not very good or authoritative. I'm just trying to give enough context so you kind of know what we're looking at in here, instead of just, oh yeah, there's a board with stuff on it. Let's talk about what these things are and just a general notion of what they do. This last guy here, this is our oscillator. So I mentioned in the intro, the first mod we're going to do is change the clock speed. So how our little processor works is it contains all the logic, but much like your computer needs a little separate circuit and a little separate battery on the motherboard to tell it, what time it is, right? To keep the system clock powered on. This little processor that's on the other side of the board, it doesn't really keep its own time. So what this little crystal does is it oscillates at a very specific set frequency. So the processor can use that frequency as kind of a baseline, and know how quickly to operate, right? Think of it almost like a metronome. So this metronome is set at a very specific speed, and then, the whole orchestra in our little chip knows to play at that speed, that BPM. And what our mod is going to do, it's going to let us change this BPM on the fly. So we can turn it up to go faster, turn it down to go slower. But when it was originally designed, it's just supposed to operate at one, set speed. Now there's several models out there of the Meowsic. I'm not going to dive too much into it in this video, because in this video, this is the one we've got. This is the one we're going to work with. But you may see this thing look like a little blue, almost like a little package. If you're familiar with what ceramic capacitor looks like, it looks like a ceramic or film capacitor. So a little blue thingy in place of this, or sometimes it's a little silver instead of like a pill shape. It's just a really tiny cylinder. And depending on which model you have, by and large, they work the same way as this one. Specifically, the only one that's different is that little cylinder one. So if you open yours up and you've got, instead of this pill shape or a blue little package looking thing, you've got a tiny little silver cylinder in kind of the same space. I just want to warn you, you're going to want to use different values for your, basically when we set up our clock mod. And I'll talk a little bit more about it when we get there. But long story short, I have, TikTok, YouTube short, whatever you want to call it, out there that talks about how to pitch mod one of these Meowsics in a super fast, lightweight form. And it breaks down all the different models and all the different values you want to use. So if you have that little cylinder, when you get to setting up your clock mod and picking your resistor and knob values, pause and go watch that video and it'll tell you what the difference is. But just to let you know, this kind of, again, thinking of it as a metronome, this one and the blue one both operate. It's marked on here in teeny tiny letters. Let me zoom in and see if we can read it. 16.38 megahertz, maybe. But the blue one and this one operate at roughly the same, quote-unquote BPM. But that little silver cylinder one is actually a really different BPM. So you just have to set up your chip a slightly different way. The mod still works and everything. You'll just, for best results, want to tune it specifically to match that oscillator. So that's what's on this side of the board. Pretty bare bones, not a lot going on. Now let's take the board off. And we'll have a peek at the other side. And I mentioned earlier that these screws are all the same size. I lied. The ones that are inside are slightly narrower than the ones on the outside. So if you're keeping your parts separate, keep these three little screws separate from all the, the million other ones you pulled off the back. Alright, so let's look at what we're seeing on this side. So on the other side of the board, we had what are called through-hole components, meaning they have little legs on them that stick all the way through the board and get soldered in on the other side. Through-hole is like the easiest thing to work with. And honestly, those old 80s electronics are pretty much always all through-hole, which makes them really easy to work with. This side is what you'll call surface mount, or SMT, or SMD. And basically these are just stuck right onto the surface using a solder paste. So you can think of it as like almost like a metal glue. It's just holding all these pieces on, a conductive glue. And that makes them a little more delicate, but what it especially does is make them teeny tiny. So you'll notice everything on this side of the board is itty bitty, which is good in the sense that it lets us make really tiny things. That's great. It's not great for circuit bending because it's really hard to solder onto these itty bitty little points. So when we get to soldering onto this board, we'll talk about ways to make life easier for ourselves. So let's just talk a little bit about what we're seeing. This is that chip, that epoxy blob. So you can see it's not a traditional chip. You know, we almost think of something like this when we think of a chip. But this is just like a big blob because it's really cheap to manufacture microprocessors that are custom, but not. It's much more expensive to put them in a nice little package like this. So when you put them inside of so when you just basically build them on the board and then blob some epoxy on top to protect it, that's way cheaper. And why a lot of these cheap little toys you might want to circuit bend are going to have this. So for our intents and purposes, all we need to know is this is the brain of the thing. And if we look down here, you can see all these little connectors that are coming from everywhere else on the keyboard, all kind of point straight into this thing. So that's a clue that lets us know, hey, that's the brains of the operation. Here, these are more electrolytic capacitors. These are just what they look like when they're surface mount. And one other thing we can look for is when we think about where voltage is coming in, where our power is going to come from, because we are going to need to leach some power off of here. And I kind of just gave it away by tapping here, but usually you'll have two bigger capacitors next to each other, and those are used for power filtering, which helps stabilize the power. You can also look for diodes, like this one here, and I don't think this one has a fuse built onto the board, but you may on other things see a fuse. And that's yet another clue that, like, oh, this is where the power is coming into the board. So we've got our diode here. That's making sure that the power, you know, if we shoved our batteries in the wrong way, and, you know, we had positive coming through ground and negative coming through positive, this diode would basically put a stop to that and say, like, this power's wrong. I'm not taking it because it'll blow up the rest of the board. No way. So that's another clue. This area here is kind of our power supply area. And the reason I'm noting that is our mod, we're going to need power for it. So we're going to come back to this section to pick up that power. And then the last thing we're going to look for, remember that oscillator right here. We can actually see, remember how I mentioned these stick through the board and get soldered in on the other side? So we can see these 2 points here are where the oscillator is soldered into place. And that is where we are going to wire in our mod later on. Let's go ahead and verify the points where we're getting power. Now the trick here is we want to find 2 points, one positive, one negative, that give us power when the keyboard is switched on, but that do not give us power when the keyboard is switched off. So what I have here, this is just a little handheld multimeter. This is nice for me because it's easier to use with one hand. I guess this is a good time to talk about it. I don't necessarily want to talk a huge amount about like gear and the stuff you need, because I'm not really the type of person to tell people to go buy stuff. It's not really my thing, but it is important to know what you need to do this stuff, especially if you're new and getting into it. So while I'm no expert, I'm not a salesman of any kind, really. I am, going to talk a little bit about, hey, here are tools that I'm using that are, like, you need them, you don't need them, they're handy for me. Here's when they might be handy. At least in this episode. Maybe I'll chill it out as the series goes on, but, for this episode at least, I feel like I'm fine talking about it. But anyway, all that to say, having a multimeter is almost a must, just because it helps you kind of check where power is, lets you check for continuity. We're only going to use really simple functions of a multimeter. So, the only thing I will say is, the really cheap ones, when you have a continuity test, they just show some information on a screen. And you really want one that will, beep. And that sounds silly, but it's hugely helpful. So, as long as your multimeter beeps in continuity mode, it'll work fine. You can get one that meets that criteria off Amazon for $5 or $10. You do not need a super expensive, really nice meter for circuit bending. So, anyway, let's get on with sorry, it keeps focusing in on the multimeter, with our check. So, A, I knew this because I've done these before, and B, like I mentioned earlier when we were kind of looking at where things are on the board, we talked about this diode, and we talked about this really big capacitor, and that was our kind of this is probably where power's coming in. So that's the first place I'm going to look. So, where this diode is, that's probably going to be the positive, and where this capacitor, where this black line is, that's the negative side of the capacitor. So I'm going to check the voltage between the diode and the capacitor. Let me see if I can get that on the screen so you all can see it. I can't really get it on the screen, but it is reading 0 volts with the power turned off, which is good. But now I've turned the power on, so let's see if there is actually power here. Sorry, that's going to happen a lot more times, fair warning. And I'm getting 6 volts between this teeny little solder blob next to our diode. That's the same thing as this end of the diode. They're connected to each other. And this hole right here, which is the same thing as this little negative pad. It is connected. And you can see that just by, it may be hard to see on here, but you can see these little lighter areas are what we call traces. So how I know those things are connected, I can see that there's a trace connecting this hole to the little pin on this negative. So I know that those are the same thing. And I can see the trace connecting this little blobby to the end of this diode, which is how I know that that is probably positive. And when I talked earlier about continuity, I'll just demonstrate real quickly. Continuity is basically a way of saying those things are connected. And as you're learning to kind of look at traces and read them, the continuity tester is like your best friend. And that's why I highly recommend having one that, like this, will beep when I make these things touch. So that way you don't have to try to look at the board, look at your hands, and look at the screen. It's too much. So, these two things that earlier I had just declared, they're touching. I can test them with my meter. And you can hear, those are in fact connected, so I can verify that all those things really are connected to each other. So as you're learning to kind of look at traces and read those, using your continuity tester just to check yourself is a really good idea. Because, yeah, that'll save you a lot of headaches than if you solder things and you realize later, like, oh no, that was actually not connected the way I thought it was. But yeah, so that's where we're going to attach our power. We've got positive here, negative here. And as we mentioned earlier, we've got our oscillator. Those 2 points are coming out here. And so we're going to attach a wire to this lower one. If memory serves, it doesn't actually matter which one. But the first time I did one of these, I just experimented back and forth to see which one I liked better. And it's one of those things where it may not have actually even mattered, but I felt like the one closer to this connector here. I'll call it the top one, because when this is flipped over, it's the top. So yeah, I'm going to attach my signal wire to that one. Again, I'm not actually sure if that matters or not. A smarter person might leave a note in the comments if it matters which one you do. But those are the 3 wires we're going to have to solder onto this board. And this process might be a little slow and painful. If you skip the intro, or just as a reminder, the way I solder is wrong because of my goofy hand. So if you don't know how to solder, do not use me as an example. Unless you also only have one hand, then, I mean, hey, it's good enough for me. Then, you know, feel free to give it a shot. But yeah, as far as, like, learning proper soldering technique, it will be much faster, much more efficient if you, you know, do things the proper way. So what I like to do with circuit bending in general is, let me zoom this out so you can actually kind of see what I'm doing a little bit. I've just cut some lengths of wire here, and I usually just cut them like way too long, because it's way better to go, oh man, I've got too much wire. You can usually just kind of like find a place to tuck it away, and it's fine. Especially the Meowsic, if you may have noticed, there's a ton of empty space in here, which is really nice for modding these. So because there's a ton of empty space in here, I'm not worried about having extra wire. The only real pain in the butt I'm worried about is if I don't have enough wire. So basically I just eyeballed it, and I know I generally want to stick my controls kind of like up here on his forehead. So I'm just making sure all my wires can reach from this board up to that area pretty easily. So I've got more than enough wire here to make my own life easier as I go through this. I've color-coded them. Black is going to be for ground, red for power, and yellow is going to be our signal wire for the clock. Now, where I got those from, because I hadn't zoomed out, I just have like a little... It's branded all over the place, and I don't want to be like, a specific brand is great, but I basically just got some off Amazon. Wire comes in gauges, and gauges are confusing because the smaller the number, the bigger the wire. The only important thing to know is this is 30 gauge wire. So anything between like 26 and 32 is going to be fine for like 99% of circuit bending projects. We'll talk about exceptions as they crop up. But yeah, one of those sets of just a pretty common gauge, again, anything between 26 and 30 should be fine. Maybe even 24 and 30. You can go to 32 if you don't mind working with tiny stuff. But yeah, that's going to be fine. Like, just get a multicolored kit, because being able to color code stuff will really kind of save your mind a bit. So next thing I'm going to do is strip these wires, and because of my kind of like goofy hand, I found it really much easier these days to kind of strip way more off the end than I need to. and then trim it down after I'm done. And if you didn't see it, when you strip wire, basically you just look at your little wire strippers there. They'll tell you what gauge, and usually if it's stranded wire, it will read a little bit bigger than it actually is. So for instance, my wire is 30 gauge, but I just stripped it using the 24 gauge setting on these. So take the little markings with a grain of salt. Obviously if you shell out and you have like a really nice set of wire strippers, they're going to be more accurate, but a cheapo set, I think these are, again, $6 or $7 off Amazon. They work great for me. The only thing to bear in mind is they're not like super precision machined, and yeah, you might need when in doubt, start at the largest and kind of work your way towards the smallest, and make sure you're not that you're just pulling off the rubber coating and not actually cutting up the wire itself. So the next thing I'm going to do, I've got a little helping hand thingy off to the side. These are useful just when we talk about tools, but again, they're not like 100% necessary. They're very helpful, regardless of how many hands you can work with, but they are extremely helpful if you don't have as many hands to work with. So here in a minute, when I solder, I'm going to turn on a loud fan. I'm not sure if you're going to be able to hear me over it. I'm hoping you can, but just in case you absolutely cannot hear me, a quick description of what I'm going to do. I'm first going to tin this wire, and tinning basically means we're just going to put a coat of solder on it. That helps all the individual strands stick together to make things cleaner. It also makes it stick to the board easier because both surfaces have solder on them. So they're more attracted to each other and will kind of just like into place. And then, when I solder it, I'm just going to move this wire into position. I'm going to use the soldering iron to heat this existing solder and basically stick the two together. And again, this is my signal wire, so it's going to go right here to this point on the top of our oscillator. Let me get a tighter shot here. So that's, again, this, now it wants to focus on the wire. But yeah, it's going to be this little point right here, which really does not want to focus on, but I think y'all can see what I'm talking about. The two little points from the oscillator, it's the one closest to this set of connectors. Oh, now it's focused. So from this angle right here. Harder for me to see in real life, but easier to see on the camera, weirdly enough. So that's what we're going to do. Now, since we've been talking a little bit about gear, I'm going to briefly talk about soldering irons. And the short version, you do not need anything fancy at all. I used like a little portable one that just plugged straight into the wall for years. I still have it and still use it. It still works great. The only downside is if you're working for like hours and hours, having an all-in-one unit where you're holding the whole thing, it'll get really hot in your hand after like 20 or 30 minutes. So the only time I decided that I needed to upgrade that, or the only reason I decided to upgrade that, is because I was doing a lot of, continuous soldering in a row. So I have a little standalone station, which means there's a little box. I'm not going to show it to you because it's on my incredibly messy desk. But there's a box where you set the temperature, and then a little handle that you hold, and it's connected back to the box. And all the conversion of, the AC to DC and all that stuff happens inside the box rather than inside your hand, so this doesn't get nearly as hot. So I would say what you do not want is you do not want the like $6 soldering iron that has no temperature control. That just like you plug it in and it's on, and then you unplug it and it's off. You don't want that soldering iron. You want something that has a temperature adjust. Now, if it's an all-in-one unit that's just like, it fits in your hand and has adjustable temperature, odds are that's fine. If you are thinking like, actually this is something I think I'm super into, I want something that I can go, you know, like an hour or so with at a time, that's fine. You can get the station one I have, I think is like $40 or $50. It's like just a little Chinese clone thing. You don't need to get like a Weller or anything like super nice like that. Like I still don't have one of those, and I'm, you know, here yapping about this stuff. So in terms of a soldering iron, that's all you need. Just look for if it can adjust temperature. It's probably sophisticated enough for you to use. I've never used one of the butane powered ones. So if you have, I'd be interested to know your opinion, like in the comments, if you think like, oh, if you're a beginner, not having to deal with wires and electricity is great. Or maybe you're like, don't use a gas powered one for a beginner. I've never used one, so I don't really know. So I'm not going to tell you to use one or to not use one, but they exist. And if you've used one, let me know what you think. I will mention I'm a safety person. I have like a fearful respect of fire and electricity. So one of the appeals of the unit I bought is it has this really awesome stand. You should note this is not on right now. If this was on, I would not be grabbing it like this. But the stand is amazing because it protects your hand and everything on my incredibly messy desk from getting burned or catching on fire. It's super stable. It's all made out of metal. I love it. This here's the tip cleaner. It's fantastic. I'm going to date myself a little bit. When I first learned how to solder, the thing to do was you used a wet sponge to like clean off the tip. And a lot of cheaper soldering kits will come with a sponge still. But these little brass cleaners, they're like a couple of dollars now. And I gotta say, well worth every penny. Buy one of these brass tip cleaners. It's so nice not having to worry about like keeping a wet sponge around and dealing with all that. So that's the one product thing with soldering that I'll be like, you absolutely must. One, temperature adjust. It has to have it. If it doesn't have temperature adjust, it's probably no good. Two, really nice, stable, sturdy base. Some cheapos will come with this little folding like wire stuck to a piece of plastic. Don't mess with that. That's super dangerous. This thing gets crazy hot. You do not want to accidentally knock it over and have it fall in your lap or roll into a pile of papers. You just don't mess with it. Buy something with a really nice base. Or buy a separate base if, you know, you really like your iron, but it came with a crappy stand. You can buy these separately. That's fine. And then lastly, the wire cleaning thing. Fantastic. Now I'm going to turn on that fan, and we'll see if y'all can hear me over it. Alright, we'll see if you can hear me, but like I mentioned, we're just putting on a nice thin coat of solder. Next up, I'm just positioning that wire. And what I've just dripped on there is flux, which helps things kind of stick to each other, and when you're soldering on PCBs, stay in their own lane. So, especially for soldering the wrong way like I do, flux is super duper important. Alright, and just in case you couldn't hear me over the fan, basically I used a big blob of flux right where I was going to solder. What that does is it helps keep the solder kind of flowing to the points where we want it to. Right, the solder will naturally gravitate to the metal traces on the board. And that's super helpful for me because when I'm soldering, I can only use one hand, and your solder itself will have a certain amount of flux or rosin or whatever it's made of. Basically, it does the same purpose as flux, but it has that already built in. The problem is you're not supposed to put it directly on your soldering iron because that flux burns away really quickly. The solder stays, but the flux burns off. So what happens if you do what I do is you basically run out of flux, things get really stuck together and messy, it stinks. So whenever I solder, I put on lots of extra flux because it's kind of necessary for my one-handed soldering. But I will say it also makes life a lot easier. It's one of those things I didn't use for a really long time because I was like, it's messy, it's sticky, I don't want to mess with it. But I gotta say, it makes the soldering so much easier. So I highly recommend learn to embrace flux, whether you need to or not. Now the next thing we're going to do, like I mentioned before, I tend to cut my wires really long and then trim them. And trimming is super important because what we don't want is to get our signal wire here, crossing, basically crossing streams with other stuff on this board. And I was about to talk about how good these little end nippers are at trimming these tiny wires. And then I made a mess of it. So, whoops. And then, just talk y'all through it, I made a mess of tiny little wire strands, and I was using the tweezers to pull them up off the board so that I can come in and clip them off. That pair is just dull. Get another pair. So there is the yellow wire attached. We'll come back and do this later, so that we'll do it all at the same time. But another useful trick to have up your sleeve is hot glue for circuit bending, which at first I thought was really goofy, but it turns out it is super helpful because it's non-conductive, it's really easy to use, and if you screw up, all you have to do is put a little isopropyl alcohol on it and it comes right off. So hot glue is super handy for those reasons. But what we're going to do is, just so that the solder isn't the only thing holding that wire on, once we've finished adding all our wires, we're just going to put little blips of hot glue on there to hold it in place. You could use super glue if you want. I've seen people do that. I've used it myself on super tiny wires. But I like hot glue better because it's easier to take off if I screw up. I always like that about it. I think I'm going to do the hot wire first. Then, just like before, in case you can't hear me with the fan on, I'm just going to tin this wire. Then I'm going to move it into position. Getting this little point right here is where I'm attaching my hot lead. I'm going to solder that in place. And one thing I forgot to mention earlier, this toy and a lot of more modern electronics use what's called lead-free solder. Lead-free solder is good in the sense that you don't breathe a bunch of lead fumes if you work in the factory where they're making these PCBs. Where it's not as good is because there's no lead in it, it has a higher melting point, it's not as easy to work with. So I personally use leaded solder because, again, I'm not breathing it in 8 hours a day. And when I do use it, I make sure to use a fan, so that I don't, breathe in a bunch of lead. But anyway, long story short, I'm running my soldering iron really hot to help my leaded solder mix in with the non-leaded solder. Having more heat helps here. Otherwise, you'd have to basically just take more time. Just to give you an idea, I've got my soldering iron set at like 375 degrees Celsius for doing these solders onto this board. I normally keep it like 325 to 350. I know some people run it colder than that, just in general, which is also fine. But yeah, when you're working on a board that has leaded solder on it, a good tip is A, use lots of flux, because that just helps smooth out pretty much everything, and B, use a lot of heat, and that will help it blend together as well. Alright, so I'm going to cut the fan on and get this one taken care of. Got that one in place. What you noticed me doing, scooting that around at the end. I was just making sure that I had, all my little wires. I didn't want them kind of going across anything. These look like they're all connected to the same trace, so it wouldn't be the end of the world if they did connect up anyway. But it's just one of those good practice things. in general, make sure you're only hitting that one very specific target as you're soldering. And the last one is going to be our easiest. So remember when we were scoping out the negative, we made sure that this hole here is connected to the negative side of this terminal. So that means it's going to be a really easy ground point to just stick our wire through and solder it in place. So what I'm going to do is get this wire tinned up. It's probably a little too much flux, but oh well. It's easy to clean up. And yeah, I'm going to tin this wire and solder it into that hole. So here comes the fan. I'm not sure if it'll focus on that. Alright, here we go. So that one, because I was at a weird angle, I ended up soldering it to that hole and the point next to it. I believe they're on the same trace. Yes, they are. Okay. I just wanted to triple check that before I moved on. As I mentioned, it's not good practice, but you know, that'll keep it in there more securely. But more so it just happened because it was coming at a weird angle and didn't want to burn up my red wire. So, you know, those sorts of things happen. So next thing I'm going to do is just clean up some of this flux. I'm going to do that using a Q-tip and some isopropyl alcohol. It's important to note for electronics, you should try to only use the 99% stuff. Just because anything else can leave a residue. Now, boards that are like already coated with something, you know, especially if it's some sort of like water resistant coating, if you're working on like some outdoor rated thing, it will sometimes react with the alcohol and make like a really weird white covering, and then that's fine, basically, if that happens to you. But if you use the less pure stuff, you can create similar coatings just out of the flux. Like, it doesn't clean everything off as well. And, yeah, you can introduce more impurities. So, yeah, just get you a little squeeze bottle, like so. Put some 99% isopropyl alcohol in there. It's not expensive stuff. And the nice thing is it evaporates super quickly. So when you're, you know, dousing your Q-tips and stuff, you can kind of get it everywhere. It'll dry right up. You can get it all over electronics. Again, why it's great. Obviously, I would not want to put that stuff all over the board while it was on, but it dries up very quickly. So when I do turn this on, it will have all dried up. It won't create any shorts. So looking at the board, everything looks dry. So I'm just going to make sure it still powers on, make sure I didn't break anything. Alright. So our keyboard still works, even with those wires soldered on. Again, I've done this board before, so I'm not super worried about it right now. But if this was your first time, what you might do is just strip the ends of your red and black wire, hook up your multimeter, and just double check, that you're getting power 6 volts when the keyboard's turned on, and 0 volts when it's turned off. I'm pretty confident we've got it because I've done these before, but if this was something you'd never bent, or if you're just getting started and want to be really thorough and go step by step, I definitely recommend doing that. It's better to figure that out now than do a whole bunch of stuff and then realize like none of your mods work because you don't have any power. If you can't tell, I've definitely done that a few times. So as I mentioned before, next step is hot glue. So I'm going to get my hot glue gun heating up here. And this is, again, on the subject of gear. You don't need like a fancy hot glue gun. I got like a cordless one just because it was like on sale or something, and I use enough hot glue in my life these days that just having a cordless one that uses like my cordless drill battery was, worth getting. And in terms of what glue sticks you use, I always try to get the high temp stuff. That could just be force of habit. I grew up in the South, and if you're working with music gear in the South, you leave it in your car, leave it in your trunk, it's easily getting exposed to, like 200 degree temperatures and stuff like that. So with anything music, I'm always a little hesitant to use, 3D printed stuff, low melt point stuff. Just because, when I think of toting gear around, that's kind of what I think of as, if you're touring in the South and chuck this thing in your trunk for a week, is it still going to work when you pull it out? I like to try to set myself up for success, right? So I do recommend getting high temp melt stuff. What I'm going to use here, just because you may not expect it, it's black hot glue, which looks super metal. But it's actually, I think it was just cheaper. So you can use clear, you can use, it's whatever you want. I've liked these black glue sticks because they're great for doing, like weatherproofing stuff on bikes where, a lot of your hardware is already black. That's why I bought the black glue sticks, and I just kind of like them. But anyway, I didn't want you to see me putting, black hot glue on this board and then think you have to buy some sort of magic special stuff. Like, nah, it's just hot glue. Whatever you might have in a craft drawer is probably fine. Again, if you have a choice between high temp and regular temp, go high temp, is my personal advice, but honestly, it's not that deep. This is just here to keep us from accidentally yanking these wires off the board. That's literally all it's going to be doing. So even if it did melt in the trunk of a car, it wouldn't matter. So. Like I mentioned before, you can just blop it on here. This stuff's non-conductive, so it's not going to interfere with the electronics. It'll just kind of harden in place. It's not hot enough to melt any solder. It'll both prevent any shorts from hitting the exposed ends of those wires, but mostly it's there just to, keep us from yanking these wires loose as we kind of move along and start messing with stuff. I tend to do that anytime I'm soldering onto an SMD, surface mount board like this, where all the solder points are tiny and are oftentimes just sat on the surface. 2 of these were through hole anyway, so those 2 probably would have been fine. Just because those have a little bit more mechanical strength to them. Anyway, I just wanted to demonstrate that because I've got the stuff right in front of me, and it's a good technique to use. That said, if you were gonna do this and you're thinking to yourself, oh no, I don't have a hot glue gun, don't let that stop you. You don't actually need to do it at all. You could just leave it how it was, let the solder do the work. You could stick a piece of electrical tape on there if you really felt like you needed to put something on. But don't feel like you need to go buy hot glue. It's not an expensive thing, so I think it's handy enough and worth the money to have it laying around. And I don't know, in my experience, everyone's got a hot glue gun laying around somewhere, right? But if you don't feel like, oh, I can't be a circuit bender because I don't have a hot glue gun, completely not necessary. When I first started, I didn't understand, no one kind of explained why hot glue was so good, which is why I took a minute to blab about it. And so for a long time I was putting hot glue on electronics. That's dumb. I don't like it. So I was very resistant to doing it for a long time, just because I had no idea why people were doing it. And yeah, now that I know, oh, it's super handy and then also really easy to remove if you need to rework something. It's actually super handy stuff for circuit bending specifically for those reasons. So I have embraced it, and just wanted to share with you all why, if you see other people doing electronic stuff, you may see lots of hot glue getting used. And yeah, I think that's why. So that's had enough time to harden, at least enough for us to flip this board over. I'm gonna be careful while we do this, but just kind of route the wires out the top so they're coming out towards this area. I realized I'm pointing at stuff you can't see. There we go. So I've got it rerouted up to this area at the top of the keyboard where we want our controls to go. And now we're going to go ahead and just put this board back into place. So I'm just going to pop these screws in. And many of you will already know this, but the best way to do this is don't completely tighten anything until all of your screws are in. And that way it just makes it easier to line everything up. If you ever find yourself with just one hand, that becomes way more important, I have found. So it's good to be, meticulous and diligent, but I have found that, with the one goofy hand, I do have to be extra meticulous about stuff like that. Just because it really helps me out. Alright, so that's in place. One thing I always like to check on these boards that have little tactile buttons on the board is just make sure it's secure enough in place that when I'm pushing these buttons on the outside of the keyboard, I can feel the little buttons pressing. Usually they design the board so you can't screw it up, but messing with older 80s stuff, I've definitely messed things up so those buttons weren't lined up perfectly, and if you find that out too late and then have to take the whole thing apart, it's a pain in the butt. So I'm just in the habit of checking that now. Alright. So the first thing we're going to do is we're going to make a little power board, which sounds maybe more complicated than it is. Basically, I'm just going to, for my own convenience, take our power wires here, route them to a little chunk of strip board, and then I'm going to use that to send power out to our different mod boards. The reason I'm doing that is just to make my own life easier. That way I don't have to like worry about fiddling with these wires too much and messing up my connections. I can know I've got good stable power to all my mods. So this also isn't necessary, especially if you were just going to do one mod to your keyboard. You could just run the power wires to your mod board. Power and ground, I should say. But let me talk about this and what I'm going to do, how I'm going to do it, and you can decide for yourself. If you don't want to do this step, it's not necessary. Like I mentioned, it's purely for my convenience. So earlier I mentioned strip board. If you're not familiar with what that is, it's basically a PCB material, but instead of being like pre-printed for a very specific circuit, it's just printed with these strips. Let's see if I can get it to focus. So you can see those copper strips on the back side of the board. So basically all these rows are connected to each other already, which makes it easy to kind of just connect components together on a board. You could just solder them straight to each other, but a board makes things more stable. Having the pre-existing connections makes the connections really stable. So this stuff is just nice to have around. Again, don't feel like you 100% must have a strip board to circuit bend. You don't. It's just handy for when you need to throw together a little circuit. Strip board can't be beat. It's super cheap stuff. And I find it more convenient than, what's it called? Project board, or basically there's a similar kind of board that is not connected in strips like that. It's just each individual hole is its own connection, and then you connect things as you need to. As you call it, prototyping board, I want to say, is what I've seen that called. So that's similar. It helps you put it on a board, makes things more stable, but having those little pre-built strips is just really handy. So I mentioned earlier, I was calling this like a power board. So in addition to just like distributing power to several different things, I'm also going to put a couple of capacitors on here. As I mentioned before, capacitors can help smooth things out. So if you use capacitors just going from positive to ground, they just kind of act like I think the technical word is a filter, but not like in the audio sense, but in the power sense. And they just kind of stabilize the power supply. So when you do that, you usually use one big electrolytic that knocks out kind of the bigger oscillations, and then use a smaller ceramic or film, this one's film, capacitor. So the values aren't super important. This one is a 47 microfarad. You could go up to whatever you wanted to, honestly. You could use like 470, it would probably still be fine. And then this one is 0.1 microfarads, I think. It's 104 is the marking. You use these a bunch with audio applications, so one of your early component purchases might be a bag of these 104 film capacitors. They're super handy for cleaning up stuff enough for audio. So all we have to do is really connect them through this strip board. Now the electrolytic capacitor is what they call polarized, meaning it has a specific positive and negative side. The negative side is marked with this big band. On mine it's gold. On most of them the capacitor will be black with a white stripe. But typically whatever side this big band is on, that's negative. So on this little strip board, I'm going to use that marked row here on the very end. I'm going to make that my negative. Or, I'm sorry, I'm going to make that my positive. And then I'm going to make the far end row the negative. So I'm just going to shove it in here like that. And then I've just bent the leads out to hold it in place while I solder it. This doesn't need to be super pretty, so I'm not worrying about making it super pretty. Now this capacitor is not polar, meaning it does not matter which side we put in positive or which side we put in negative. And so you can see I've got those two capacitors in here. And then I'm going to cut a couple sets of red and black wires that will attach to this board and use for attaching our mod boards later. So there are some wires. Again, I was very particular with the length because there's plenty of room to stack stuff on this board. Now I'm just going to strip one end of these for now. I'll strip the other end when I'm ready to connect the mod boards to it. But one thing I've found, especially with the one-hand thing, you may not find this very useful, but I found it helpful, is when I'm soldering a wire to a through-hole connection like this, I go ahead and strip off quite a lot of the end of the wire, like kind of an absurd amount. And then I can just feed it through, bend it like it was a solid wire, and then trim off the extra once I'm done soldering it. So, I don't know. You may find that easier, you may not. I found it really helpful. Alright. Like I mentioned earlier, having the really long tails on these is nice because I can just shove that length of wire through. It helps if you kind of twist the end together first. There we go. And what I'm being careful to do when I twist it like this, and one of the reasons why it's helpful to have such a long tail on these is when I clip these, I really want to make sure I don't end up with any extra frayed wire anywhere. Because if anything shorts from positive to negative, that's really not good, basically. So, all of this to say, you know, it's handy for avoiding that. Just because that would be disastrous. When I say disastrous, I mean it's 6 volts. Even then, it would probably just pop and fizzle. It would probably break the keyboard, but it wouldn't, you know, it wouldn't hurt you or anything. So I don't think so. You'd have to really screw up, I think, to hurt yourself with one of these. Alright, so what I'm going to do, I'm going to fire up the soldering iron. And put flux on all of these and get them soldered in place. So here comes the fan. clean up these ends. And that is a more important step than it might seem like. Just because it's really easy to forget to clip these little ends off. And then you start putting things back together. And they end up shorting everywhere. And yeah, it can turn into a whole mess real quick. And if you're just starting out, especially when you have like longer ones, I would say start saving, not the little stranded wire bits, but like these little ends of the capacitors, your little component ends, and just start throwing them in a little bucket. They come in handy all the time for making short little connections. So having a stash of those around is always good. Okay, and I'm just double checking to make sure I caught all the fiddly little ends, so nothing's gonna short out and break on us. Alright. And there we have it. That is our power board. Oh, you know what I didn't do? I didn't connect the power to it, which is an important part. Whoops. First, I'm going to take the power wires that we soldered onto the keyboard earlier. And just like before, I'm going to strip these down. I'm going to strip a ton off the end just to make my life easier. So try to remember to actually get what I'm doing in camera. Alright. Alright. Those through, and just same thing again. So here comes the fan. Now that I've got the power hooked up, I'm just going to double check, make sure nothing's broken. So we've got the power on. And I'll try to position this where y'all can see it. There we go. Okay. So as you can see, I'm getting 6.25 volts across the board. And with it turned off, I should get no volts. Alright. So That means everything is working. No smoke came out of here. So that is a good sign that I didn't wire anything up wrong. So take a little break, and then next up we're going to start getting our clock mod put together. So we are going to prep our clock mod board. So before we get too into that, I'm going to talk a little bit about what this board is. First, full disclosure, this little clock modder by Peter Cat Productions, that's me. I make these. I designed them for me. I thought other people would think they were cool, so I put them up for sale, and yeah, they do pretty well. Other folks seem to like them. So I want to point out, you do not have to buy this board from me. I think it makes life easier, and I'll talk about why. But you don't have to buy this specific clock modder thing. All you really need is this little chip right here, and that's the LTC1799. This is basically just a really nice oscillator with a really wide range. Remember, we talked about that little pill-shaped oscillator and how it's kind of like a metronome set at one standard speed. Well, this is like a metronome where you can adjust the speed, and it has a really wide range of different speeds that it can do. So the chip is really the only thing you need, but you'll notice, I mean, this chip is tiny, 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 and it's surface mount, which is not super easy for most folks to work with. Most folks are used to through-hole soldering. So one thing this board does is it converts this itty-bitty-bitty chip to through-hole. So that just makes it easier to work with. Full disclosure, you can also just buy boards that convert this teeny tiny sized chip to a little breakout. They're super cheap on Amazon. The other thing this board does that I think makes it worth it is it's pre-soldered, so you don't have to do the SMD soldering yourself. Right here, it's got a little capacitor built in. Remember, we built a little power board with some capacitors that's going to smooth out our power supply, but you're not always going to have that. So having it built onto this board means you're going to be able to smooth out your power, because this thing is a little finicky about power. It does like really nice clean power. The other thing it does is it has a spot where you can load a trim resistor, and we'll talk a lot about what that does when we get to it. So just kind of hold that in the back of your mind for now. And let's talk about the different connections we have down here. So first up, we have our voltage and our ground. Pretty straightforward. This is just the power that the chip uses to operate. Here we have rate 1 and rate 2. I have them marked RT1 and RT2. These are going to go out to a knob that's going to let us control that rate. So remember, we said you can kind of think of an oscillator like a metronome, and the rate is basically the speed that metronome goes. So we're going to connect those two to this knob, and then as we change this knob, we'll talk a little bit more in depth about how it does that. But as we change the knob, we're going to change the rate that this clock goes, basically speed it up or slow it down. And then finally we have the output. So remember, we soldered that yellow wire onto our existing oscillator. When we wire this up, we're going to create a switch that's going to say output this clock signal to that yellow wire, and basically override that static clock that's built into the keyboard with whatever we have this thing set to. So basically we're just kind of jumping in and replacing the built-in clock with the clock signal coming out of this itty-bitty-bitty chip. So, I mentioned this trim resistor thing before, and why I think it's cool, and why this board makes life a little easier. So let's talk about that. So this knob, if you're not familiar, let me just set it on here so it'll focus. You may already know this, but this is called a potentiometer. And what it is it's basically a in the configuration we're going to use it, it's a variable resistor. So when I turn the knob all the way to the right, these two pins are going to have no resistance between them, or effectively no resistance. There's always going to be a little, theoretically, but there will be no resistance here, and there will be max resistance between these two. Same if I turn it all the way to the left, there will be no resistance between these two, and max resistance between these two. So, when we talk about potentiometer values, see this one is marked as B50K. 50K refers to that 50K refers to that max resistance. So, when this is turned all the way to the left, the resistance between the two rightmost pins should be right around 50K. There's like a little bit of a margin of error, but so that's what that resistance rating is. That's the maximum amount, not the minimum or anything. The minimum with a potentiometer is 0. And the B, that talks about basically the pattern of the resistance. So B usually means linear. So what that means is as we turn this knob, the exchange between the resistance here and here, it's linear, right? It just makes a straight line if you graph it out. There are also logarithmic pots. Those will be marked with an A, or reverse logarithmic pots, which are marked with a C. So those are typically used when you're controlling audio, because if you were using this directly on an audio signal to control volume, audio doesn't go in a linear path. If you're familiar with how decibels work, you're probably familiar with that already. But basically, those trace, instead of a linear path, a logarithmic path. And mostly you're going to see that in audio applications. Even though you might think, hey, this is a keyboard, isn't this an audio application? We're not using this potentiometer on an audio signal directly. We're using it on just a voltage signal. So, in this case, linear is exactly what we want. It's going to make it more predictable. So, how this chip works is the resistance. What we're doing here is we are setting a resistance between the input voltage, which powers the chip, and basically one of these pins is a control pin. And the more resistance we put between the voltage and that control pin, the slower the clock speed is going to be. The less resistance we put in between those two, the faster the clock is going to be. Now remember, like I said, the minimum resistance for this is always going to be 0. But the problem is, with 0 resistance between this voltage and this rate, this thing is going to go really, really fast, and it's going to crash our keyboard. And the same is true of almost any project. So what the trim resistor does is it just sets a minimum resistance. So instead of saying we're going to go from 0 to 50K, if I put a 1K resistor here, that means instead of going from 0 to 50K, I'm now going from 1 to 51K, right? And that way I can't turn it all the way down to 0 and make things go crazy. Now, for each individual project, you should kind of play around with this value and see what you like. Use the knob to figure out the maximum resistance, and the trim resistor to set the minimum resistance. And what that lets you do is it lets you really tune this control. One of the things that I always disliked about circuit bending is, the unpredictability can be fun, but if you want to play something, and make it more musical, it needs to behave with a certain amount of predictability. So, knowing it's not going to crash when we turn our knob is really important to me. So, that is what the trim resistor does. So let's go ahead and get out our trim resistor. And the first thing we'll do is get that installed. And as you can see, I was playing with this resistor at some point before the leads are bent up. So I just checked it with a multimeter real quick to make sure I knew what value it was. I got it right. It is 5.1K. So that's always a good habit, is just kind of double check values, especially if you're disorganized like me. Now you'll notice on this board, where this trim resistor spot is, there's a teeny tiny trace with a little scissor icon above it. And basically, just to make life easier, you don't actually need to install the trim resistor, so I leave these points just connected by default. So to connect a trim resistor, our first step is just to cut this trace. So I'm just taking an X-Acto knife here. I'm just going to kind of work it up and down and side to side a little bit. Once I've got a little notch, I kind of like to do this, like, press down and turn it to kind of like lift the trace up. And that helps me really know that I've separated that. And then, of course, to check and make sure we successfully cut that, I'm going to use my continuity tester on my multimeter to see if we have continuity still. Alright, so you can see I've got continuity up to the cut. But no continuity between those contact holes. So you probably couldn't see that, but yeah, I did double check and made sure my cut worked. It did. But because I always worry about these things, I usually just kind of give it a quick double check. Run this around here, make sure there's no loose copper floating around in there. It could cause something to short. And again, wouldn't be the end of the world if it did short. Basically what would happen is it would ignore our trim resistor. So it wouldn't like blow anything up, it would just make our trim resistor not very useful. Alright, so basically I've just popped my resistor in there. Bend the leads out so it doesn't move on me. And then I should be able to flip it over. And voila, we're gonna solder those 2 points together here. So here comes the fan. Right. And I don't know if you probably couldn't hear it over the fan, but it kind of brings up an interesting point. If you did hear me, I was actually blowing a second ago. And if you watch soldering tutorials, people will be like, don't blow on it. It doesn't cool things down. Worst case scenario, you get some spit in there and, pollute your solder joint, which would not be good. So, just to explain why myself and other people sometimes blow, it's not about like cooling down the solder joint, because, you know, you're working with the kind of temperatures blowing on it wouldn't do anything. Really, it's about keeping the lead-filled smoke like out of your face. So if you hear me blowing while I solder, I'm usually just like blowing a wisp of smoke away from my face. Even though I've got the fan going, it's not always powerful enough to grab it from far away. And yeah, that's just a little low-tech way to keep from breathing in as many lead fumes as possible. But if you hear that, don't think, oh, I just have to blow it out of my face. I don't need a ventilation or a fan or anything. You definitely should if you're working with lead and solder. But that is handy for keeping it out of your face. And next up, we are going to solder a couple of wires in place for our rate knob. And much like we did before, I'm not going to be super picky about the length of the wire. Green and yellow. That is nice. Alright. So just like before, there's plenty of room inside the Meowsic. I'm going to cut nice big lengths of wire so that, you know, we have plenty of flexibility when it comes down to placing everything. And like before, I'm going to strip off kind of an unnecessarily long amount of wire just because I find that's easier. If you don't find that's easier, that's fine. I am curious to know what other people think. Honestly, soldering wires through holes used to frustrate the hell out of me. And then one day, just being super frustrated, I just got stripped off a really huge amount of wire. I was like, let's see it fall out of there this time. And lo and behold, it didn't fall out of there. It was much easier to just place the wire, bend it into place, and it actually kind of stayed there and did what I wanted. But yeah, leave comments if you're like, that's a terrible idea, or you hate that, you love that, whatever. Curious to know what other people think of that. Since it's not something I've seen other people do, just found it helpful myself. Now, what I'm doing right now is just arranging the wires to make sure they're kind of pointed off the edge of the board. What you don't want is your extra wire to be pointing where it could accidentally cross over one of the contacts. So that's why I'm kind of being careful to bend it over the side of the board. I don't really care if these ends touch each other because I'm going to cut them off anyway. I just want to make sure that where they're coming out of the hole, they're pointed away from any other possible points of contact. With that said, let us solder those in. Here comes the fan. Alright, so those are in. Alright, get those trimmed up. And I'm not going to bother cleaning up the flux just yet, because we got to solder more wires in here shortly. But one thing I did forget to mention, let me turn this around so y'all can see what I'm talking about. These two rate pins are marked as rate 1 and rate 2. And I did use different color wires in them, kind of like out of the forced habit. But I do want to point out, it doesn't actually matter which direction rate 1 and rate 2 are. All we're doing is changing the resistance. Basically, there's a trace going between voltage plus and that control pin. But instead of making that a direct connection, I split it apart. One end is connected to rate 1, and then the voltage is connected to rate 2. So whatever resistance we put between here, resistance doesn't really have a direction. So it doesn't matter which one's rate 1 and which one's rate 2. What matters is the resistance we're putting between rate 1 and rate 2. I just realized I forgot to mention that earlier, so don't think you have to, like, pay super close attention to which one's the yellow wire, which one's the green wire. It literally doesn't matter. So for the next part, we're going to hook up our potentiometer. So I'm going to load it into my handy grabber thing here. And notice I used this one before with incidentally the same color wires. So I mentioned before which one's rate 1 and which one's rate 2 does not matter. But which of these two sets of pins we use does matter. And it doesn't matter in the sense that either one will work as long as you use two that are next to each other. And if you used the two outside pins, for example, actually that's the only way it wouldn't work is if you used the two outside pins. Basically, like we talked about before, when you're adjusting the resistance between these two pins changes, and the resistance between these two pins changes. Now, when we turn the knob clockwise, in most things that people are used to, clockwise is up and counterclockwise is down, right? Think about any volume knob you've ever turned. If you turned the knob this way and it turned the volume down, or worse, you turned the volume knob this way and it got louder, you'd be like, what the hell? This is backwards. So in the same sense, we're going to hook it up to these two pins, because as we turn it clockwise, the resistance between these two pins gets lower, meaning the clock goes faster. So it does matter that we use these two pins specifically, the two on the right. If we used the two on the left, it would still work, but as we turned the as we turned the post clockwise, the resistance would increase, making it go slower. So that would just feel weird. So when I say it matters, nothing's going to blow up, nothing's going to break if you get this wrong, but it will feel weird because it'll feel backwards. So yeah, just use the rightmost two pins and it will kind of feel more like you kind of intuitively expect it to. First, what I'm going to do is I'm just going to scrape these wire ends off. The official fancy way to do that would be to use some copper braid and clean off the old solder, remove the wires, but this is circuit bending, we don't need to be fancy. I'm just going to heat it up with an iron to melt the solder and just scrape it off, and leave the old solder on there. It'll be fine. Alright, and you may have noticed after I scraped that on, I put a little bit of new solder on there. The reason for that is you never want to just leave old solder and keep melting it and melting it and melting it. Like I was mentioning earlier when I talked about flux, basically there's flux built into your solder to help things kind of flow move more easily, but as you keep heating the solder, that burns off. So what you don't want to end up with is like old, really crusty, it'll kind of look dull looking solder, because basically it just doesn't work as well, because you've burned off all the flux and rosin, or whatever you want to call it, and yeah, it just makes for a much worse connection. So you always want to, when you're reflowing or working with old solder in any way, you always want to make sure to add some new solder on. That's my very low-tech understanding of it. I'm sure like a metallurgist or someone who didn't barely pass chemistry would have a much better explanation of that. Now, what I find helpful for these, again, this is more of a one-handed thing, so your mileage may vary. You don't actually need to make these little like wire loops like I'm doing. You can just put a bit of solder on the end of these and just stick them on there using your other hand to hold the soldering iron. I think that's what most people tend to do with these. But because I'm working with one hand, I find it more helpful just to make these little loops and hang them on the pins like that. And then, yeah, I'll just come back and solder those on. Just wanted to point that out. If that looks like super tedious, you don't have to do that. That's a one-handed thing. But also if you're, you know, if that looks like it would be helpful to you, by all means, give that a go. It certainly doesn't hurt anything. Alright, I'm going to solder these on. So here comes the fan. Alright, I've just trimmed the ends off my loop, and I don't know if I talked about it while I was doing it, but I did wind these wires around each other a couple times before I soldered them, and I didn't do it super tightly, you know, do it however you please, but this, when we start installing components, is going to help keep these wires kind of together since they're going to the same place, and it'll just help keep things a little tidier. I'm really awful at cable management, as I'm sure you'll see before this is over, but I do just want to point that out, because even if you're terrible at cable management and you don't care what it looks like, this will just help you keep your sanity, because those wires will kind of always go together. So it's always a good trick, just wind them around each other, even just a couple times. You don't have to make a nice spiraled wire or anything. Alright. And next up, we are going to attach our switch. And like I mentioned earlier, what the switch is going to do is it's going to let us turn our outside clock signal on and off. And that way we can, if we want to use the keyboard normally, right? For instance, if we really want to play a specific C or something like that, if we've got the pitch mod on, that's like really hard to do. But, the keyboard is designed to be able to play a musical note. So just turning off the clock mod is the easiest way to do that. So that's what the point of the switch is. So now I'm just grabbing a wire roughly as long as my yellow and blue wires. Again, I've got plenty of room in this project, so I'm not super concerned. While I am getting this set up, a quick note on switches. So, there are a bunch of different kinds of switches, and they have a special nomenclature that I am really bad at remembering. I believe, and someone please, fact check me on this one, but I believe this is what's called an SPST, single pole, single throw switch. Or I'm sorry, this is an SPDT. DT? Yeah, single pole, dual throw, because... Wait, no, single pole, single throw. See, I always get it wrong. So someone in the comments can tell us the right one, but the way I think of it, and you'll see it noted sometimes, is there are on-off switches, and there are on-on switches, and there are on-off-on switches. This is an on-on switch. So what that means is when this switch is swapped, or when this toggle is switched this way, these two pins are connected. It basically flips a little lever inside to connect these two. And when it's flipped this way, it turns these off and turns these two on. That's why it's an on-on switch. So you can switch these two on, or you can switch these two on. An on-off switch will also work in this application, because we're not actually going to use our third pin. We're just using two of these pins. So an on-off switch is actually only going to have two pins, and that's perfectly fine. So if your switch just has two pins, you're good to go. If you have three, just make sure you use the middle one, and one of the outside ones. Much like with the pot, if you use the two outside ones, that's the only way you can actually screw this up. So I just wanted to point that out because, we've only got two different positions, and that's exactly what we want for this project, is a simple on-off switch. So because this one can be, an on-on switch works just fine. Yeah. There are also switches, the on-off-on that I mentioned before, that are just like this, but they actually have like a center position where none of the pins are connected. And those are super useful, but we do not want one of those in this particular case. It wouldn't hurt anything, it would just be confusing to have three different positions to just turn something on and off. So I've got this lined up, and let's get it soldered. Here comes the fan. And one last note, since this is a super cheapy little switch, I find it's really easy to accidentally overheat them and make it so that the internal stuff doesn't work. So after I solder, I always like to flip it a couple times just to make sure nothing's getting overheated or stuck in a position. And B, usually I err on the side of holding the iron on something too long, because that's for a better flow. It's generally the better side of caution to go with. But in this case, I try to go really fast and keep my iron as far away from this plastic as possible and just go as quick as I can. That will prevent you from burning up these switches, because it is really easy to do with these super cheap ones. And you can just buy nicer switches, but switches get surprisingly expensive when they start being the higher quality ones. And for circuit bending projects, it's nice to have bunches of switches. So if I was doing this on a commission, obviously I'd chill out for the nicer ones, but for something we're doing to a toy, I'd rather just use the cheapy ones that are, super affordable, and I can get a big bag of them for a few bucks. Now we're going to swap back to our Clock Modder Board here. Now I'm going to connect this switch to the output pin, because that is where the clock signal's coming out. It's routing into the switch. We'll connect that to our yellow wire on the keyboard that we previously set up, and then the switch will let us toggle between the clock coming out of this little chip and the clock that's kind of preset on the keyboard. Just making sure the tail of this is pointing away from any other contacts. And now it should be ready to go. Here comes the fan. Next up, we just need to wire this all to the keyboard. And just to kind of remind ourselves, so we have our power board here. It's going to output our power to our mod boards. And then we've also got there it is. We've also got this yellow wire coming from our clock signal that was built into the keyboard. So first we're going to hook up our power. Now this is a really small chip. It's really easy to find a place to stick it. Again, with so much room on this keyboard, I'm not worried too much about it. You'll notice one of my power wires is a lot longer than the other. Not on purpose, just kind of ended up that way. So because this one's easier to find a home for, I'm just going to use the shorter set of power wires for this guy and save the longer set for our other mod, since that is on a slightly bigger board. But that is just a minor little thing, nothing to stress about. Just double checking to make sure this outside one is our positive voltage. Very good. Now let's get those soldered in. Here comes the fan. Right. I'm just taking a little extra care with those wires, because again, we do not want to get positive and negative short-circuited together. Definitely want to avoid that. So, now we have everything wired onto our little clock mod board. Next, we just need to wire up the other end of our switch. So at this point is when it starts getting really easy to tangle up wires. I'm really good at tangling up wires. Just as you go, try to untangle things. Or in my experience, you can get really tangled up really fast. Alright. Like I mentioned before, because... Was that a frame? Because these are super cheapy switches, I'm going to try to go fast. Here comes the fan. So that's definitely not my prettiest work, but that is fine. Alright, switch still seems to be switching like we expect. Alright, now before I move on to the next mod, or especially before I start drilling any holes in anything, I always like to test things out. That's why I kind of wire this all up with extra long wires, is, that way I don't have to, if you wanted things to look really tidy, you would mount all your hardware, and then you'd run wires to just the right lengths from A to B, blah blah blah. But, we're circuit bending a toy, it's not that deep. So instead I've just put plenty of wire on everything, and that way now we can just test this thing out as is. So without further ado, we've got our switch set to the off position. Again, when it's flipped this way, that means our external clock is disconnected, so it'll just be using the regular clock. We expect it to turn on and just behave like normal, and turning this knob shouldn't do anything. Alright. So mission accomplished there. Now let's see. And sometimes when you switch on the clock, it'll kind of crash, just because if it's at too far of an extreme all at once, that kind of overwhelms it. So what I've done is I've set the potentiometer roughly to the middle-ish, and then I'm going to turn this on using its internal clock, just because it's going to boot up more reliably with its internal clock. And then we'll cut on our modded clock and see how it goes. It would help if I flip the switch the right way. There we go. So as you can see, our trim resistor isn't quite enough. As I turn this up, it's basically still able to crash out. But the good news is it's not crashing completely. As soon as I turn the clock back down, I don't have to like actually reset the device. So for these purposes, I'm just bending this one as a test for my little LFO and to make a video on. So I'm happy with it. If this was something I wanted to use in like an exhibit, or, again, if it was a commission or I was going to sell it to somebody, I would go back and adjust my trim resistor and just add a little bit more resistance onto it. It probably wouldn't need much at all. But the trick for doing that is just turn it really slowly and then stop as soon as it crashes. Alright, and then what you can do is now you measure the resistance. And I'm barely reading anything on there. So even just putting like 100 extra ohms or something like that will probably work. The other thing, since we're pulling the voltage from the batteries, and I just opened this up with brand new alkaline batteries in it, it's putting out a little over 6 volts. So as those batteries start to get older, this knob is going to have a little less voltage to put down, so it'll probably stop crashing once those batteries get a little worn down. Also, if I use rechargeable batteries, which have a slightly lower voltage, it probably won't crash like this. So that's another reason why I'm not going to bother fixing it, is even though, it just barely has enough room to crash right now, just changing the batteries to rechargeables, I think we'll fix that. And I was checking to see if I had some handy that I could just demonstrate that with, but sadly I don't. But that's my theory anyway, and again, this is just a circuit bent toy. I'm not using it for an exhibit or anything, but if you were bending this and you weren't happy with that, again, you would just add a tiny bit of resistance onto your trim resistor and call it a day. So yeah, with that put together, I think that's going to be it for this video. I'm going to put together a second video where we do the LFO mod next. Anyway, thank you all for tuning in. I appreciate it if you made it this far. Your typical like, subscribe, bell stuff always feels lame to ask for, but it genuinely does help out, especially for a teeny tiny little channel like mine. So if you're into the circuit bending stuff, if you thought this was remotely entertaining or useful, I don't know how entertaining it is, but maybe it's good to fall asleep to, I don't know. But yeah, if you enjoyed any of that, subscribing, liking, bell thinging is a great free way to support this. It definitely helps out to see some of that stuff come in. It helps motivate me to keep making more stuff. In addition to helping YouTube not just like ignore the fact that I exist. So anyway, thank you all so much, and check in soon for the follow-up video where we're going to wrap this up by adding our LFO and getting all our controls put in place.